Okay, so this is the first of many, many, many examples that you're basically going to be doing the same thing over and over again. This will basically be the first steps in your problem-solving process. We have P Nutty Company dry roasted shelled peanuts placed in jars by machine. Here's the information. Alright, so if I have X is approximately normal with 16.1 and 0.15, right? Without doing any calculations, which outcome is more likely? Randomly selecting single jar, finding the contents weigh less than 16 ounces, or randomly selecting 10 jars, finding the average content is less than 16 ounces. Well, averages are less variable than single events. Therefore, we expect it to be less likely to have the average content of 10 jars be less. Okay? Any one jar may be less, but if I took 10 jars and averaged them, it would be less likely that the average of those 10 would be less. Okay? Then, find the probability of each event described above. Right? So, we have X, which is approximately normal, with 16.1 and 0.15, and we want to find the probability that a single jar is less than 16 ounces. Right? Need the z-score for that. Let's not therefore there, that would be a semicolon. The z-score would be 16 minus 16.1 divided by 0.15. If we put that into our calculator, we get approximately negative 0.67. Okay, so then I'm looking for the probability that the z-score is less than negative 0.67, which from my table is about 0.2514. Right, so about a quarter of the time, right, the probability is for selecting a jar that has less than 16 ounces. Right? But X bar, right, with 10 jars, it's going to be approximately normal because I come from a normal distribution. So X bar is approximately normal with 16.1 and 0.15 all over root 10 as its standard deviation. Okay. The z-score here will be 16 minus 16.1 divided by 0.15 all over square root of 10, right, which is approximately negative 2.11. So I'm looking for the probability that X bar is less than 16, which will be the probability that Z is less than negative 2.11, which from our table is about 0.0174. Right? So yes, much less likely that the average of the 10 is less than 16 than any individual one. Okay? What's the most common error? The most common error comes from this standard error. The most common error is forgetting to divide sigma by the square root of n. Okay? Forgetting to divide sigma by the square root of n. Now, FYI, if sigma is not known, then we will use S and have a t value rather than a z value. Okay, very important.